Hi everyone, I'm Brock. So today the academic paper I want to review is called YOLOv7, Trainable Bag-of-Freebies sets new state of art for real-time object detectors. And the reason why I want to research on this one is because I go to the article, Google Scholar, most influential papers for 2024. And this paper, YOLOv7 is listed. Let's start. So what is YOLOv7? YOLOv7 is a real-time object detector that can identify and locate objects in images or videos at extremely high speed. YOLO stands for you only look once, meaning the entire detection process can be completed in a single forward pass through the network without the multi-step process required by traditional methods. That's cool. Imagine walking into a crowded supermarket. Your brain instantly identifies objects like people, shopping charts, shelves, and products, and know where they are. YOLOv7 is like an artificial super eye that mimics and even surpasses human ability. It sees fast, 161 frames per second, and sees accurately. Oh, that's cool. Core innovation explained, trainable bag-of-freebies. What does it mean? Bag-of-freebies refers to techniques that only increase training costs, but do not increase inference cost, which is actual deployment cost. Think of a chef who spends extra time practicing knife skills during training. When actually cooking, they are not slower, but rather faster and better. The trainable aspects mean these tricks are not fixed, but it can be automatically adjusted and optimized based on the model and the data. Okay. What does it mean for specific freebies? Firstly, planned reparameterized convolution. Second one, coarse-to-fine lead-guided label assignment. Three, batch normalization fusion. Innovation 2, extended efficient layer aggregation networks. E-ELAN is a new network architecture proposed by YOLOv7. Traditional E-ELAN reaches a learning saturation point when computational blocks are stacked to a certain depth. E-ELAN uses a group convolution to expand channel count and cardinality. Then enhance the feature diversity through shuffle, and merge cardinality operations. Okay. It seems that all those complex concepts in computer science actually can find some metaphor in our normal life to make it easier to understand. Innovation 3, compound scaling for concatenation-based models. Traditional model scaling methods like efficient independent depth resolution scaling don't work well for concatenation-based models. In such models, changing depth also changes the input width and transition layers. But YOLOv7 proposed a compound scaling method. Simultaneous scaling the depth and computation blocks and the width of transition layers to maintain the optimal model structure. Which means if you want to increase a building from 5 to 10 floors, you can't just add floors, which is depth. You also need to think the support pillars, which is width. Otherwise, building become unstable. YOLOv7's compound scaling follows this same principle. I think that this metaphor is very, very easy to understand. Innovation 4, deep supervision with, how to pronounce, auxiliary head. Deep supervision is a training technique that adds extra auxiliary heads in the middle layers of the network. YOLOv7 calls the head responsible for final output, the lead head and the head used to assist training auxiliary heads. YOLOv7's key innovation is a coarse-to-fine lead-guided label assignment. The leader head generates fine labels for precise learning. The auxiliary head uses coarse labels with rather relaxed positive samples constraints to improve recall. The auxiliary head's learning is guided by the lead height, similar to generalized residue learning. I don't know what he's talking about. What is generalized resident learning? I feel, even if I read the paper, there are a lot of terminologies I actually either forget or didn't learn that before. So a metaphor is like a research team where the lead researcher, which is a lead head, does precise research while guiding research assistants, which is auxiliary heads, to do broaden preliminary surveys. The assistant's work helps the lead discover overlooked details. This is residue learning. Okay, some core technologies. First one is model reparameterization. So, what's reparameterization convolution? Like learning to swim. During practice, you might use resistance growths and fines to train various techniques, which is multi-branching training. But in competition, you remove all A's and use only on your most refined strokes, which is merged inference. The training A's don't slow you down in competition, but make you stronger. Okay. YOLOv7's key finding is that the identity connection in wrap convolution reparameterization convolution has a destructive effect on architecture that already has residue or concatenation connection, like REST-NITE and DenseLite. What's REST-NITE and DenseLite? Therefore, YOLOv7 proposes planned reparameterization using repconv-n without identity connection and layers that have residue or concatenation connections. 2. Dynamic label assignment. Traditional objects detects use hard label assignment. Fixed rules like IOU threshold determines which entry boxes are positive or negative samples. This is like an exam that rigidly divides pass or fail by a fixed score threshold. But a dynamic label assignment is more flexible. It adjusts the labels based on the network's own prediction quality. For example, the YOLO serials use the IOU between predicted and ground truth boxes as a soft label for objectiveness. This is like a teacher dynamically adjusting teaching difficulty based on each student's learning progress. Item 3, E-ELAN Architecture design. Extended, efficient layer aggregation network. E-ELAN's design considers 3 key factors, such as gradient path length, controlling shortest longest gradient path for effective deep network learning, and convergence. Second part is parameter utilization. Avoid stable state destruction from excessive computation block stacking. Third one is feature diversity, which using group convolution to let different groups learn different features. Actually, I have a question: how convolution learn, makes a model learn something? How that happen? Okay, there are also some. Item 4 is implicit knowledge from YOLO-R. Implicit knowledge is combined with convolution feature maps in addition and multiplication minus in YOLOv7. At inference, the implicit knowledge vector is absorbed into the parameters of adjacent convolutional layers, adding 0 inference cost. Okay. Item 5, exponential moving average model. So an analogy is like tracking your daily weight. EMA doesn't just look at today's number, but considers trend from all previous days. This eliminates the effect of daily random fluctuations, giving a more stable and reliable result. Okay, cool. And here's some key terms. So YOLO, you only look once. AP, average precision. MAP, mean average precision. FPS, frames per second. F, flops, floating point operations. IOU, intersection over union. NMS, non-maximum suppression. COCO, common objects in context. CSP, cross-stage partial. ELAN, efficient layer aggregation network. I feel that, when I'm reading those papers, I feel what I'm doing in college, I find for most of those terminology, I actually have no idea what they're talking about. It's too specific. Now I feel that, the knowledge base is so big. Even if you get a master's degree or PhD degree, if outside of the domain you spend years researching on, you still have no clue what's that talking on, for another field. So I feel that, how to learn, maybe the way how I learn need to be improved. Yeah, that's some source I have. E-ELAN, extended E-ELAN, FPN, future pyramid network, RAPCONV, parameterized convolution, BN, batch normalization, SILU, sigmoid linear unit. Okay, BoF, Bag-of-Freebies, EMA, exponential moving average, deep supervision, lead head, auxiliary head, soft label, model scaling, group convolution, cardinality. Oh, okay. Architecture. YOLOv7's overall architecture follows the classical three-stage object detection design: backbone, neck, and head. Okay. So input the image, then go through backbone. Then it will be going to different features such as low-level feature, medium feature, and high-level features. Then go to neck, which will do a feature fusion. And then go to different head, detection head. And then after go to the head, do post-processing. Then finally output the bounding box, class, and the confidence. Okay. Okay. So the backbone extracts hierarchy features from the input image at multiple resolutions. And the neck will fuse multi-scale features from the backbone to create rich representation for detection. As for PAFPN, it will add the bottom-up path of FPN, strengthening information flow from low-level to high-level features. And the data pipeline. So raw image, go into letterbox resize, then do data augmentation, then do normalization, then backbone, then neck, then head, then NMS, then detection result. When I began, the more academic paper I read, I find such a pattern. The first thing is that when we don't know how to solve this problem, actually we use a pretty complex workflow to fix this problem. And then after we get, more get a better understanding about how to solve this problem, we began to, use some more straightforward way to solve this problem, right? And then our workflow actually become much simpler. I noticed that that seems to be some common pattern when we learn something new or when we try to solve something new. Okay. So letterbox resize paths the shorter set of the image to maintain aspect ratio during inference. And the mosaic augmentation combines for training images into one, enriching contextual diversity. Okay. Okay, and the YOLOv7 design complete model family from edge devices to cloud GPU. Okay. Training architecture, input image, backbone, neck, intermediate feature, final feature. Intermediate feature is for auxiliary head. Final feature is for lead head. Lead head will do prediction. A lead will get label generation. And they also have fine label and a coarse label. Fine label is for lead head loss. The coarse label is for auxiliary head loss. Calculate total loss, then back propagation. Well, I think that I still get some high level feeling about what this algorithm works, but still a lot of details I'm not very don't know very well. Okay. You know, YOLO has 10 versions, shows how popular it is, right? So the first author is Qing Yao Wang. Okay, pretty young. The interesting thing is that in like AI area or well, if I look into the history, young people actually a lot of people who made great achievements are young people. Maybe just because young people has nothing to lose or just start from scratch, right? So, which means that and adopt to new things much faster. So, but no one but no one can resist aging, right? So I think that the way to at least reduce the fixed mindset when we grow older and older is keep forcing ourselves to understand new things rather than say, hey, I already know everything. Yeah, I think that pride is the biggest obstacles to to innovation. Okay. Mm, okay, that's really impressive. Yeah, this analysis is more on the marketing side. Key takeaways. Free lunch does exist. YOLO V7's most profound insight is through carefully designed training strategies, model performance can be significantly improved without adding any inference cost. This challenges the traditional belief that accuracy and speed must be trade-off. Interesting. Insight 2, small teams can outperform big companies. A 3-person academic team surprised models from Google, Microsoft, Baidu, and others on the speed accuracy trade-off in object detection. The key is deep domain expertise and continuous incremental innovation. If we do things fully rely on physical ability, most of the time, more people means great power, right? But if things depends on the head, our mindset, our thoughts, or the so-called intelligence or wisdom, whatever, number actually doesn't make as much sense as animal. We say 三个臭皮匠顶一个诸葛亮, but in real life, most of the cases it doesn't work this way. A 诸葛亮, well, it should be more like a 一将三军易得，一将难求. It's easy to get a soldier, 10 soldiers, or even 10,000 soldiers. But it's hard to get an excellent general or excellent leader. So which means that as a person, we should always, if we want, always to keep improving our mindset, how we think, how we influence. That's very, very important. Last night I talked with my parents, have a video call with my parents for about 3 hours, and especially my mom, shared so many stories inside the big family, right? Who are relatives, but have blood relationship, but not directly my brothers or my parents' brothers. Sometimes I feel, it's ridiculous because people in their 50s, even, 60s, I don't know, maybe 50s, which is in my parents' generation, how they still make some mistakes from the perspective of mine. It's irrational. It's incredibly irrational. Why, right? Again, it's all about how we look at the world, how we understand the world. If we just live like an animal based on instinct, I think it's a pity to have the opportunity to live as a human for such 100 years. Well, go back. Insight 3. Gradient path analysis as architecture design compress. YOLOv7 use gradient flow propagation path analysis to get both network design, which is E-ELAN, and parameterization strategies, which is planned RepCom, proving that a theory-driven design is more efficient than pure empirical trial and error. Well, maybe. Okay, here's some ecosystem. Here's some YouTuber. Yeah. Yeah, I think, this is a data source. So to generate this report, I use some scripts I used before. I use some scripts to generate, okay. use the original PDF, use GitHub data, okay, and search online to get information of the author, and search online to get some commercial related stuff. Well, that's pretty much for this academic paper. Yeah, thank you everyone. Bye.